Hi guys, today I'm going to introduce you to something called the electromagnetic spectrum. So the electromagnetic spectrum takes up all of the different types of radiation that come from the sun, and today we're going to look at a tiny sliver within that spectrum called visible light. And visible light comes to us in the form of color. Now, today we're going to look at what we call the primary colors of light. You may also hear them referred to as the additive colors of light or additive color theory. So the additive colors of light are red, green, and blue. This is not a mistake. I am also not trying to tell you that your art teachers have been wrong all these years, telling you that yellow is a primary color. But when we look at the colors of light, yellow is not. We are just looking at red, green, and blue. When you look at crayons and pencil crayons and things, that's completely different, and you'll see today why that's different. So we cannot create red light, green light, or blue light using any other combination of lights. However, all other colors can be formed by using just those three. So when we combine those colors, we get what we call the secondary additive colors. So they are created by combining only two of the three primary colors of light in equal parts. So if I combine an equal amount of red with blue, I get a color called magenta. Now, of course, if it's not an equal amount and I have a little bit more red, my color will lean towards being on the pink side. If I add more blue, I will get something that's a little bit more of a purple. If I take green and I add it to red, I get yellow. If I add a little bit more red, then of course I get an orange kind of a color. If I take blue and add it to green, I get a color called cyan. If I add all three together, well, you got to wait just a moment to find out what's going to happen there. So what I'm going to do is just switch screens here, and I'm going to turn all three of these lights off. So if I take the red light, and I combine it with the green light, there we get yellow, just like I told you earlier. Now, if we were at school, we'd be doing this in the classroom, and you'd see that it would not work nearly this well. So I turned off the green, I'm going to add some blue, and I get that really nice magenta color. Well, now I'm going to turn off the red, I'm going to add blue and green, and there's cyan. Now, if I add all three together, I don't know what you're expecting to see, but I bet it wasn't white. And the reason this works is because all of our colors come from the sun. They all started as white light, and the reason that we see different colors is because they travel at different wavelengths. Wavelengths there. And we're going to learn a whole bunch more tomorrow. For now, we're going to go back to where we were, and I'm just going to find the page I want. And right here, you're going to find this activity from page 10 in your booklets. So we're going to fill this one out together. If I've got blue, red, and green light, I combine them, I get white. If I take just blue and red, I will get magenta. Blue and green gives me cyan. Green and red will give me yellow. So take a moment, fill in that piece. And if you have some colors at home, you can do the next part too. So if we've got red light, we want to color this red, and you combine it with green light. In here, you would color it yellow. So we would have some red, some yellow, some green. You want to color this one blue. Blue and green would give us cyan. And if we combine our blue with our red, we get magenta. So you might be wondering, so what? What I have here is the same picture getting closer and closer and closer, and this is all about pixels, which is what you are going to see in the next video.
Pixels. You've heard of them by now. They're the little things in the screens of our computers, tablets, and even the phones we carry in our pockets. People talk about dimension, resolution, DPI, PPI, pixel density. But what exactly is a pixel? Wikipedia defines a pixel as the smallest controllable element of a picture represented on the screen. Every screen on any given device is made up of several hundreds, thousands, or even millions of pixels. If you look really closely, you'll see that a pixel is just a square of color. That's it, a block filled with a single color. Now, when all these pixels on the screen are filled in with different colors, they create the images we see on our devices. So now that we've established what a pixel on a screen is, how does it work? Let's say this block represents a single pixel. Now, inside this pixel, and every other pixel, there are 3 different colored lights. They are red, green, and blue. These 3 colors light up in sequences with varying brightness in order to create the color your eyes see. If the color of a pixel should be purple, then only the red and blue lights will be lit. From your viewing distance, the pixel will look purple. And with just these 3 colors, each pixel can generate over 16 million distinguishable color variations. Truth be told, there is a lot more to pixels than mentioned here. Those were just the basics, but it's quite impressive for such a tiny thing, don't you think?